You know, I hope you understand how much I care for you and how much I'm willing to suffer in order to give you your knowledge and understanding of chemistry. But someone has to do it, right? So today, we're going to talk a little bit more about substances, and when you put those substances together, you get something that we call a mixture. Stick around. Now, a mixture is when you have a combination of two or more pure substances in which those substances still retain their individual chemical properties. Now, we can have varying degrees of how well those substances mix together, and for that matter, with all the substances we have in the universe, there's an infinite number of mixtures we can have. It's also important to understand that most of what we see around us is a mixture. It's very rare that we have something that's not combined with something else. Two types of mixtures we need to talk about: heterogeneous mixtures and homogeneous mixtures. A heterogeneous mixture happens when you don't have uniform blending of your substances. We see this concept in things like Italian dressing for a salad. You have an oil component and a vinegar component, and those two don't actually blend together. So because of that, that would be a heterogeneous mixture. The salad itself is a heterogeneous mixture. It does not blend uniformly. You can still see where the lettuce ends and the croutons begin. So again, if there's not a uniform blending of those substances, that would be a heterogeneous mixture. Now I have a homogeneous mixture. Here I have a mix of salt and water. The salt dissolves in the water very uniformly, so much so that I can't see where the salt ends and the water begins. It's all one uniform mixture. Homogeneous mixture. We also call these solutions. So a solution is a homogeneous mixture. Now in a solution you have two parts. You have a solute and a solvent. The solute is what is dissolved. It's the smaller amount in that mixture. So here we have salt as a solute in this salt water. The solvent is the thing that does the dissolving. It's usually in a larger amount in the mixture. In this case, water is the solvent in this solution. You encounter solutions probably on a daily basis. Sweet tea, lemonade, these are examples of solutions. Sweet tea, you would have a solvent of water, once again, and solutes of tea and sugar. Now, if you put ice in that sweet tea, I guess technically you could call that a heterogeneous mixture, since the ice doesn't uniformly blend with the tea. But I think you get the idea. Solutions don't have to just be solids dissolved in liquids. There are other types of solutions. We can have gas-gas solutions. The air that we breathe is a gas-gas solution, a mixture of nitrogen and oxygen and those trace gases I talked about previously. We can have examples of a gas-liquid solution, like when we have oxygen dissolved in seawater. In this case, the oxygen is the solute and the water is the solvent. We can have a liquid gas solution where droplets of water could be suspended in the air that we breathe. In that case, the little water droplets are the solute. Now it sounds weird, right? Water being a solute. But in this case, it's the smaller amount. The air is the solvent. How about a liquid-liquid solution? When it rains, obviously that rain, that fresh water, combines with the seawater. That would make a liquid-liquid solution. We've already described a solid liquid solution, in this case the solute, the salt, being dissolved into the solvent, the water. But what about a solid-solid solution? Is that even possible? As a matter of fact, it is. For example, every day we use metals that are blended together very uniformly. We call these blends of metals alloys. So an alloy is a type of solid-solid solution. Remember I said before that most of the time the things that we see around us are mixtures. So what if we want to separate those components? How do we go about doing that? Well, it depends on the type of mixture. So for that, let's go inside. Okay, well, the first type of separation technique is simply that of filtration. Filtration is when you have some sort of porous material like this paper here, and we are separating a heterogeneous mixture. In this case, I have a solid that's suspended in this water here, and it's not going to dissolve. So I want to separate the two and get the solid out. I'll simply pour it into this funnel that's lined with this filter paper, and it will allow the water to pass through, and it will separate that solid from the water. So basic filtration, our first separation technique. This method of separation is called a distillation. Now, a distillation works to separate a homogeneous mixture, that is, a mixture that's completely uniform, based on the respective boiling points of the substances in that mixture. Okay? Let me show you how it works. And what I've done here is I've got some water that's contaminated. It has other things in it besides water. Now, pure water boils at 100 degrees Celsius. And the odds are really good that the other things in here don't boil at 100 degrees Celsius. So what's going to happen is this. I turn on the heat that heats my mixture, and it'll get to the point where this mixture begins to boil and begin to produce vapor. Now, the different substances are going to boil at different temperatures. So the first set of vapors may be less than 100 degrees Celsius. That's not water. And there may be some things in there that boil at higher than 100 degrees Celsius. That's not water either. I want 100 degrees Celsius. You might ask, well, how do I know what's what? Here's how. As the vapor begins to rise, it's going to go up to this point right here, and you might notice I have a thermometer. The bulb of the thermometer is right here, this junction point between this column and this portion of the apparatus that we call the condenser. As it does, this thermometer is going to read the temperature of the vapor passing by as it goes into the condenser. As vapor comes into this condenser, the outer part of this condenser is cooled by running water. You see these hoses that are going into the condenser. I hook the hose up to the sink, and the running water passes through the outer portion of that condenser, and it causes the inner tube of the condenser to be cool. So as the vapor reaches the condenser, that cooled outer tube causes it to condense in that inner tube, causing it to become liquid. And that liquid will then drop out at the end here. So, if anything is less than 100 degrees, I don't want to collect that because that's not going to be water. So to begin with, I'll remove my collection flask. And perhaps I'll just put a beaker underneath to catch the waste before we get to the 100-degree mark. So when this vapor keeps passing over the bulb right here, the bulb with the thermometer, and it finally causes the thermometer to reach 100 degrees Celsius, that's when I know that's my water, my pure water. And it's at that point that I'll reattach my collection flask and enable me to get the clean water as it condenses in this tube right here. So that's how distillation works in a nutshell. Again, it separates a homogeneous mixture based on the respective boiling points of the substances in that mixture. Okay? Another separation technique is called chromatography. Chromatography is a technique that separates the components of a mixture based on the ability of each component to travel across or sometimes be drawn across the surface of another material. Now we call the components of the mixture the mobile phase because those are the things that are moving. The stationary phase is that material that they're being pulled through or drawn across. Now, the reason why the separation occurs is because those components in that mixture will have different strengths of attraction for the stationary phase. For example, the various components in the ink and the line drawn across this chromatography paper will have different levels of attraction to this paper. If I partially submerge this paper in just a little bit of water, that water is going to travel up the paper. And as it does, it's going to pull those components in the ink across the paper. Remember, the different components are going to have different degrees of attraction to the paper itself. So as the water pulls those components, they're going to be pulled at different rates. You want to see? Let's see how it works. So there you have it. We see that the components, the mobile phase, the things that are moving, travel across this paper, the stationary phase, at different rates, and thus they are separated. We can also separate mixtures by means of sublimation. The sublimation occurs when you have a solid that passes into the gaseous phase without going through a liquid phase. So it just goes straight into the gaseous phase when you add heat. And if you have a mixture and one of those compounds or substances in the mixture sublimates, then you can separate that one from the others by simply heating. So here we've placed a mixture of compounds in a dish, and we've placed it on a hot plate, and you might be able to notice the white vapor coming off of the dish. That is a compound that sublimates. So this compound that's in this mixture is sublimating while leaving the rest of the components behind. We can also undergo separation by means of crystallization. The crystallization occurs when we take a solution and we put a dissolved substance into that solution. So much it's to the point where we can't put any more into that solution. No more will dissolve in that solution. If we put just a little bit more than that, then that dissolved substance is going to start coming out of solution in the form of crystals on any available surface at all. And in performing this crystallization, we're actually going to get very pure solids from it. Sometimes heating is used to put even more of that dissolved substance into the solution, and then it's allowed to cool. And once it cools, we can put a string into the solution or a tiny bit more of that substance, and it will cause crystallization to occur. Look at that. You see the crystallization happening right in front of our eyes, filling the entire beaker. That's how much dissolved solid there was in that solution. And you can see how it crystallizes once it has just a little bit of something added to it. So there you go. Crystallization. How we can get pure solid from dissolved solids in a liquid. That's enough fluorescence for one day. I think I'm gonna head back out. So the question of the day actually is a two-parter. I have two different mixtures. I want you to tell me how you'd separate each of these mixtures. The first mixture is iron filings and sand. How would you go about separating those two? That's part A. Part B is, how would you separate a salt and sand mixture? That's all the time we have for today. Today we talked about heterogeneous and homogeneous mixtures. How heterogeneous mixtures are not uniformly distributed, but homogeneous mixtures are. How we also call homogeneous mixtures solutions. We describe different types of solutions, like gas-gas solutions, gas-liquid solutions, liquid-gas solutions, and so on. And then we spent just a little time discussing how we can actually separate some of these mixtures. I hope this has been informative for you. I know I've had to suffer through and agonize in order to give this chemistry knowledge, but I feel like it's worth it. Well, I better go, because it looks like this seagull is about to pick my pocket. So until next time, God bless.